This video is to cover 4.7, and we're going to start off with number 3. Now, number 3, we're going to take a whole number 30 and divide it by a mixed number, which is 2 and 10 over 17. So in this section, we're going to be dealing with mixed numbers, which are a whole number combined with a fraction. We're used to seeing fractions such as proper fractions that look like that, or improper fractions that look like this, because we've learned that the numerator, when it's larger than the denominator, that is considered an improper fraction. Okay, so how do we handle this problem? Well, first of all, we're going to express 30 as a fraction, and to do that, we write 30 over 1. Now, to convert the next mixed number to an improper fraction, 2 and 10 over 17, we're going to take 17, multiply it by 2, and then we add in 10. So I'm going to write that out as 17 times 2, and then you add in 10. And the denominator never changes. And the answer to that is 44 over 17. Now I'm going to use both of these fractions in my problem. So I'm going to go over here and I'm going to write it out. 30 over 1 divided by, and then I have 44 over 17. Now what we've learned in our previous sections, to divide fractions, we need to first convert that to multiplication, and then we multiply it by the reciprocal. And the reciprocal, remember, is just the reversed order of that fraction. So let's go ahead and write that out. So if I have 30 times, and the reciprocal, which is 17 over 44, we've learned we just rewrite it as one fraction, which is 30 times 17 all over 1 times 44. Now we're going to evaluate that and say, what can I factor out so that way I can simplify this fraction before I finish multiplying it out? Well, I see that 30 and 44 are both even numbers, so I was going to try a 2. And I know 2 times 15 is 30, and I also know 2 times 22 is 44. So let's go ahead and rewrite it with our factors. So I have 2 times 15, and then don't forget your times 17. And then we have 1 times, and we'll express the 44 as 2 times 22. Now you evaluate, we'll say, well, the 2's will divide out to 1. And if you look at the top, you're not going to get a 22 out of the 15 or 17, and vice versa. You're not going to get a 15 or 17 out of the 22. So you can't simplify it any further. So we just multiply across, and we end up with a value of 255 on top and a value of 22 on the bottom. Now that is an answer. That's an improper answer, though, improper fraction. And if you read your set of instructions, it's going to ask for you to enter a mixed number as your final answer. So how do we've learned how to convert up here from a mixed number to an improper fraction, and we did this in section 4.1. So now we're going to take this improper fraction and convert it back to a mixed number. So if you recall how to do that, we're going to take it and convert it into a division problem like this, the old long division problems we've worked with back in our earlier education days. Now, the shortcut, if you just go ahead and enter 255 divided by 22 in a calculator, you can write the whole number. Now, when you enter it, you're going to end up with some kind of answer as 11.09, blah, blah, blah. I don't know what the digits are, but you can't include any of that, but you can take the whole number and just write it up here on the top. Now you just go ahead and take 22 times 11, you plug that into the calculator, and when you do it, you'll end up with a result of 242, and when you subtract those out, you know, with a remainder of 13. Now the 13 remainder is your numerator, and the 22 is your denominator. So you can see here and here, the denominator never changes. So to convert that, your final answer would be 11 and 13 over 22, and that's what you would enter into the system. So this was number 3. So let's move over to number 4. So number 4, we have 3 and 2 over 9, and we're going to multiply that by 1. And sorry about this writing. Let me write that a little bit better. So 3 and 2 over 9 times, and then you have 1 and 3 over 7. Now, again, to multiply that, the first step would be to convert it to an improper fraction. So I'll start with them over here on this side. So that would be 3 times 9, and then you add in the 2 all over 9. And then this one would be 1, 3 over 7. So to write this would be 1 times 7, and then add in your 3, and that's all over 7. So when we perform the multiplication and addition, we should end up with 29 over 2, and this one will be 10 over 7. So now we're going to use these fractions in our problem. So I'm going to go over here and write it out. So we have 29 over, let me make sure I'm writing this correctly, 9 times, and the next fraction is 10 over 7. Okay, we've learned all you have to do is write that as one fraction. So we have 29 times 10 all over 9 times 7. We do an evaluation. Is there anything we can factor out to reduce it down? And when you go through the process, there's nothing you can do. So we got to multiply it across. And our answer is 290 over 63. Now that is an answer, but it's an improper fraction. So we need to go ahead and convert it because they're going to ask for a mixed number as a final answer. So I'll go ahead and write 63 divided by 290. I'll enter that in a calculator. I'll get a whole number of 4. So 63 times 4 will give me 252. I subtract those out and end up with a remainder of 38. So my answer to this would be 4 and 38 over 63. And that's converting it. And that's your final answer for number 4. All right, let's move over to number 5. So number 5, we have 2 and 1/3, and that's divided by 1/5. So immediately you should think to yourself, well, I have to convert the mixed number to an improper fraction and then set it up. So if we have 2 and 1/3, we know that's 2 times 3 plus 1 all over 3, and that is a fraction of 7 over 3. So we're going to use that. So if I have 7 over 3 divided by 1 over 5. The first thing we've learned is that, okay, to divide that, we have to convert that to multiplication, and then we need our reciprocal. So let's write it out. So we have 7 over 3 times 5 over 1. Write it as one fraction. See if we can factor anything out. We cannot, so we're just going to multiply across, and we have 35 over 3. Here's our improper fraction. We're going to convert it to a mixed number, so it becomes a division problem. And then when you enter this into your calculator, you end it with a whole number. And then we know that 11 times 3 is 33. We subtract out, we have a final remainder of 2. So this is expressed as 11 and 2 over 3. There's our mixed number, so there's our conversion. All right, let's move over to number 6. Okay, number 6, now we're going to change our thought process. We're no longer multiplying or dividing. Now we're going to deal with addition. So this is a little bit different. Now, if we have 2 and 3 over 14, and we need to add it to the whole number of 9 over 14. Now, how do you handle adding and subtracting mixed numbers? Well, you don't have to convert it to an improper fraction. We only do that when we're multiplying or dividing. All you're going to do in this instance, you're going to add up the fractions, and then you're going to add up the whole numbers. So the first thing you're going to say to yourself, well, are these fractions like fractions? Well, we know if it has the same denominator that yes, it's a like fraction. So all we need to do at this point is just simply add up the two numerators, and when we do that, we'll end up with an answer of 12. Oops, let me change my color. So we'll end up with 12 over 14. That seems pretty simple. And then 2 plus 1 is 3. But let me rewrite that. So we have 12 over 14. But you can see that fraction's not in simplest terms. So I'm going to go ahead and rewrite that part as 2 times 6 over 2 times 7. Now I can get these 2's to divide out to 1. And my final answer now has been reduced, and it's 3 6/7. That's your final answer, because your instructions will ask for simplest terms. Now, the other part of number 6, it's going to ask you to do an estimate. So let me rewrite that. So estimate. Now, the process for this is the same thing when we're rounding numbers. We've learned if the numbers between 1 and 4, we don't round up. But if it's 5 or between 5 and 9, we do round up. So the same process is just like these fractions. So if we have a fraction like 2 3/14, which is above, and then I have 1 9/14. So now when it rounds, we're going to be looking at the whole number itself. So let me back up a little bit. So let's just look at these numerators. So that's a 3 and that's 9. So this 3 falls under this range, so we know nothing's going to round up. So this 2 will remain the same. So we'll just write a 2. Now when we look at the next one, which is a 9, the 9 will make this 2 count up, or the 1 count up to a 2. Sorry about that. Don't mean to sound confusing. So again, let me back up. What you're going to do, you're going to look at the numerators of the mixed number. When you see the numerator, if it's between 0 and 4, then this whole number will not count up. But if you notice the next one, which is a 9, it is between the range of 5 and 9. So this number 1, it does count up to 2. So now that we have our whole numbers, all you're going to do is add those up, and you have an answer of 4. So that's the estimated answer. That's the process you have to go through to get that answer. Hopefully that wasn't too confusing. All right, let's move over to number 7. All right, number 7 is 2 3/4, and we're going to add that to 5 1/8. All right, so again, the same process. You're going to be adding these, and then you're going to add your whole numbers. But if you notice, these do not have the same denominator. So we go through that process we went through in the previous sections where we come up with the lowest common denominator, and then we have to come up with equivalents with that lowest common denominator. So if you can easily see, instead of going through the whole process of coming out with the multiples, you should see that the lowest common denominator for these fractions, it is 8. Now to come up with our equivalent fractions, I'm going to set the fractions up and write it out, 8 and 8. And we've learned that we go through the process. 1 times 8 is 8, so 1 times 1 is 1. 2 times 4 is 8, so 2 times 3 is 6. So now that we have our fractions, we're going to rewrite the problem with our equivalents. So I'm going to go over here. So I'm going to have 2 6/8, and I'm going to add that to 5 1/8. Now they are like fractions. I can go ahead and add those. So I have 7/8 and then 7 here. So that is our final answer. All right, see how much time I have? I think I'll go ahead and continue on part 2 with the next problem.